Hi, AP Statistics. So I'm here to quickly go through two examples of the one sample t interval for estimating a population mean. We've already developed these procedures in class. I just want you to have a video so that you can see exactly how to conduct this procedure to generate an estimate for a population mean using your calculator. We will, in fact, do one example using statistical measures and one example using the actual data set, so you can see how both can be used in your calculator to compute your values. In terms of computing this interval by hand, we've already done that in class, so I'm not going to go through that in this video. So this is a summary again of the procedure for using this test statistic t to estimate a population mean. We do always have to check the conditions, as with any inference. Random and 10% condition when sampling without replacement. And then we have this large sample normal condition. Either we can make use of the central limit theorem. If our sample size is bigger than 30, we meet that normal condition. Otherwise, we have to have evidence from our sample that it's reasonable to believe that the population is distributed normally. So we'll see an example of that in this video. You have that formula again, but we will be using the calculator to do that chugging along so that we can get that interval generated for us and we can focus on the interpretation. So the first example we'll look at is in our unit packet, and it is about a particular question on the AP Statistics exam. So suppose about 220,000 high school students took the AP Statistics exam in 2018. Looking at one of the 5 free response questions, we can see that, which is scored on a scale of 0 to 4, we can see the distribution of our sample of 30 students depicted to the right. And though it appears strongly skewed, since our sample size here is going to be at least 30, we've sampled 30 students, that's not going to be a problem for us. We have the summary values of the mean and the standard deviation, and our goal is to construct and interpret a 99% confidence interval for these data. So we're going to use the 4-step process state, plan, do, conclude to answer this question. And the first thing I'm going to do, since my goal is to estimate the mean or average score, is state that I am going to use a one sample t interval. That's going to give me my mean. I do have to meet the conditions for inference before I can do that. So in planning it out, I'm going to check the 3 conditions. Random. I was told that this is a random sample of 30 students, so we meet that condition. Since I'm sampling without replacement, I will need to check the 10% condition. So 10 times our sample size would give me 300. That is less than the reported population of 220,000. So we're good on both of those fronts to start. The last condition is a condition for the distribution of the sample statistic x bar to be normally distributed. And since our sample size is 30, by virtue of the central limit theorem, we will meet that condition. So we're good on the conditions. Then it comes the do part. And for that, I'm going to go to a calculator. I'll click on the statistical menu and scroll immediately to the tests submenu. Here's where I'll find all my values, and the t interval is actually option 8. So I'm going to scroll down to 8 and hit enter. It's then going to prompt me for all of my statistical measures. So I can go ahead and plug in the mean and standard deviation. Those are the sample data into their corresponding locations. So I'll plug in 1.267 for the mean and 1.230 for the standard deviation. It will also prompt me for the sample size, which was 30, and what confidence level I want to use, 99 for this problem. I'll go ahead and click calculate, and it's going to go ahead and compute the interval for me. So I don't actually have to do the computations myself. I will transcribe this interval and the summary statistics along with them. And I recommend anytime you're doing an AP question of this type to also write the formula down just to guarantee partial credit in case you mistype something into your calculator. It's also good to copy these down so that any reader can see exactly what statistical values you had. And it's at this point helpful to double check that you did in fact plug them in correctly so that I did not make any mistakes. So we're all good on that front. I've error checked myself. That should be the correct interval. The last thing I'm going to do is interpret that interval, and we have a stock interpretation framework that we use. Essentially, we are whatever confidence it is, 99% in this case, that the parameter of interest, the mean score for this question on the 2018 AP Statistics exam, is captured by the interval blank to blank, in this case, 0.648 to 1.886. So there is my confidence interval and interpretation. This problem is done. Pretty straightforward. So what other circumstances can we run into? Well, we had the benefit in this case because our sample size was 30. So we met that large sample condition in part 3. What happens if we don't meet that condition? So here is another example where my sample size is only 18. I was only able to get a sample of 18. In this question, as part of their final AP project in AP Statistics, Jeff and Juliet randomly selected 18 rolls of generic brand toilet paper and measured how well each brand, this brand could absorb water. To do this, they poured a quarter cup of water onto a hard surface and then counted how many squares of toilet paper it took to completely absorb that quarter cup. These are the results from the 18 rolls. I want to construct and interpret a 95% confidence interval for the true mean number of squares of generic toilet paper needed to absorb the water. So that is my parameter. It's already defined for me. Okay, so my snag here is that I only have 18 rolls, so I'm not going to be able to make use of the central limit theorem. So I have to know that this data is normally distributed. So does this data set give me reason to believe that it's distributed normally? If it's not, then I'm not going to be able to use the T procedures. So that's kind of the trick in this case. So let's also make sure that all the other conditions are met. For doing a one sample T interval, I was told that Jeff and Juliet did randomly select the values. And in addition, the sample size of 18, it's reasonable to believe there's more than 180 rolls of toilet paper in existence. So the first two, definitely good to go. Since the sample size doesn't meet the central limit theorem, the way I can confirm the data is normally distributed is in one of two ways. I could, option 1, plot the data and see if it's reasonable to believe that I have a symmetric normal curve. Essentially, in that case, we'd be looking for the absence of outliers and the absence of strong skewness. These data are, in fact, slightly skewed to the left, but it's not strong enough for me to believe that if I was to take a larger sample, the data wouldn't take on a more normal shape. So slight skewness is totally fine. Strong skewness is a problem. You can check this. You don't have to make all 3 of these graphs, but you can make any one of these. And looking at any one of these graphs, they're all different depictions of the same idea: box plot, histogram, dot plot. From the histogram, I can see that though I have slight skewness, there are no outliers or strong. So there's no evidence, there's not enough evidence to doubt that the population is normally distributed. That's how we meet the condition in this case. You could also do this with the box plot, and you can create these graphs in your calculator. If you go to Statistics, Edit in the calculator, you can type the data set in as I have done here. And if you go to Stat Plot and turn your plots on, I'm going to construct a box plot of these data and then do zoom 9 to view my box plot. So that is fairly symmetric, slight skew to the left, but not strong. No reason to doubt that the data is normally distributed. So that is probably the quickest way to check this condition if you don't meet the large sample condition. You could also, if you want a non-ambiguous way to look at this to check the shape of the distribution, another graph that we did earlier in the year is called the normal probability plot. If you construct a normal probability plot for these data, if you find that there is a strong linear association in that plot, that's evidence that the data is distributed fairly normally. I can see that strong linear pattern in this data. Again, you can create that in your calculator by going to Stat Plot and selecting the final option in the graph window. That is the normal probability plot. You do zoom 9. I get a fairly linear pattern here. So that is another way that we can check this condition. So you can do either of those two options. You do not have to make all of these graphs. Any one graph with the associated interpretation is sufficient to meet this condition. So we've definitely met the condition in this case. So now I want to actually do the construction. So now that the conditions are met, we can construct the interval. I'm going to return to my calculator. I'm going to click on the statistics button, return to tests, and I want to do a t interval. Now, because I already have my data set typed into list 1, I'm going to use the data option here rather than the statistics option. And I'm just going to tell it that all of my data is located in list 1. The other thing I need to do is tell it what confidence level I want to operate at, and I want a 95% confidence interval. This is kind of the nice thing. If you type all your data in and you use the data option, your calculator is going to automatically compute the summary statistics and plug them in for you. So when I press enter, it's going to construct that confidence interval and report all of my necessary information. I'm going to go ahead and transcribe that right onto my problem, and that is the entire do part of this confidence interval. I have the interval reported along with the summary statistic values. The last thing I need to do is interpret this interval in context, so I can say that we are 95% confident that the parameter of interest, in this case, the true mean, forgot what the question was, the true mean number of generic toilet paper, pieces of generic toilet paper needed to absorb a quarter cup of water is captured by this interval. So I'm just going to, for the interest of time, say mu, but when you're actually writing this, you would fill that full written explanation out, is captured by the interval 23.52 to 26.37. So in general, the average number of pieces of toilet paper to absorb a quarter cup of water of this generic toilet paper should be somewhere between 23.5 and 26.4 pieces. Okay? So those are the two situations that you could be in. You may have to use your data. You may need to use summary statistics. Both can be plugged into the calculator. If you meet the conditions for the central limit theorem, that's the best case scenario, as long as you have a large enough sample. But if our sample size is not large enough, we can still check the reasonableness of that distribution by looking at a graph of our data set. So the final question I want to answer for you in this video is kind of, how skewed is too skewed, or when might this distribution not meet the conditions? So I want to quickly look at an example of meeting the conditions for using T procedures, using 3 examples here. So I'm looking for, again, either I meet this large sample condition, sample size more than 30, or the absence of strong skewness and outliers. So I'm going to give you a moment to look at these 3 questions. And based on these observations, I want you to tell me whether or not you believe it is safe to use T procedures. So take a moment, pause this video, and test your thinking on these 3 questions. Okay, so I'm going to go over them very quickly. So these are the correct responses based off of the given information. A, it is not safe to use T procedures. I cannot construct a confidence interval using the 1 sample T interval for that question, but it is safe for B and C. So why is that the case? The first one, my sample size is only 5, and I have a clear outlier at around 5.8. So because the sample size is small and there is an outlier present, it is not safe to use T procedures. For question B, question letter B, though there are 2 outliers, which is a worry, the sample size is 100. So the sample size being 100 is large enough to make use of the central limit theorem, and those outliers are not going to affect my overall procedure. So since the sample size is bigger than 30, I don't have to worry about the outliers or skewness at all. Okie dokes. What about the third one? So there is some skewness, but this is not strong. There is a slight right skew, but if I had a larger sample, it's quite possible that that distribution could balance out and be a little bit more symmetric, look a little bit more like a normal curve. So we're going to assume that it's normal unless there's evidence that it's not. So there is slight evidence of skewness here, but it's not very strong. So though there is skewness, it's not strong enough given the fact that I've sampled 20 students. The fact that my sample size is 20, it's approaching that magic number at 30. We're going to forgive that skewness a little bit. Whereas if my sample size was like 5 and I had strong skewness or an outlier, that's a little bit more worrisome. Again, more data, more reliable inference. So the larger my sample size, the better it is. So that's a quick overview. If you obviously are going to have some questions about like when exactly is the skewness or the outliers a problem, when not. So we can clarify that when we're back together in person. So until then, I will see you guys. Take care. Happy calculating.